Okay, so this time we're solving quadratic inequalities rather than linear inequalities. Now, if you've seen one of my previous videos, how to solve quadratic equations by factorizing quadratics. So what we do, we set up our double brackets to factorize this quadratic expression. Just note how I'm also including the inequality signs here and the zero. So back to factorization. I've got to think of factors of 12, or pairs of numbers that multiply to make 12, but also add together to make -7. So here's a clue. It's going to be there's going to be a couple of negatives in there. So I've got to think of factors of 12, which are negative numbers. Well, we've got -3 and -4, haven't we? -3 times -4 is +12. -3 add -4 is -7. So I can put into my brackets x minus 3, x minus 4 is greater than or equal to 0. So now when we were solving for quadratic equations equal to 0, we would just simply look at the bracket and think, well, what the sum in that bracket needs to equal 0. So we would say x is 3 in this case, and x is also 4. Okay. Now we do the same thing here for quadratic equations, but it's quadratic inequalities, but it's slightly different because it's an inequality. So what I suggest you do with these two numbers here is draw a little number line between them, 3 and 4. And what we're going to do is this. We need to pick a number in front of 3, before 3, in the middle of them both, and after 4. We're doing this because we need to know where the inequalities lie to satisfy this quadratic inequality here. We need to know where the solutions lie. So let's pick a number less than 3. I always recommend pick 0. It's nice and easy. So let's say x equals 0. Let's substitute it into here. 0 squared is 0. -7 lots of 0 is 0. 0 plus 12 equals 12, which is greater than 0. So that suggests that x can be less than or equal to 3, because we know that 3, when we substitute 3 into the brackets here, that gets us 0, and anything times 0 is 0. And remember, it's greater than or equal to 0 is our quadratic inequality. So any number in front of 3, before 3, will satisfy this inequality. So we can already put, I'm just going to make a little box here, we can put that x is going to be equal to or less than 3. Okay. Now let's pick a number which is between 3 and 4. Okay, so unfortunately we've got a case where it's going to have to be, we're going to have to pick a decimal, we can't pick an integer because there's no integers between 3 and 4. So let's pick 3.5, shall we? And if you want to avoid squaring 3.5, you can just pull it into these brackets here, the factorized brackets already. So if x is 3.5, or 3.5, let's substitute it into those brackets there. So we will end up with 3.5 minus 3 times by 3.5 minus 4. Now 3.5 minus 3 is 0.5, and 3.5 minus 4 is -0.5. Now You don't really have to work this out because you know a positive times a negative is a negative, and any negative number will be less than 0. But we need our inequalities to be greater than or equal to 0. So we know now that the solution cannot lie between 3 and 4. Okay, it can't lie between 3 and 4. So now what's left to do is to pick a number more than 4. So let's pick x equals 5 and plug it in. So we've got, plug it into our brackets here. So we've got 5 minus 3 and then 5 minus 4. So 5 minus 3 is 2 times 5 minus 4 is 1. 2 times 1 equals 2. So we can now say that x can be greater than or equal to 4. So any number equal to 4 or more than 4 will satisfy this inequality here. Okay. So just to recap, we factorize our quadratic, we solve the brackets to each equal 0, we draw a number line here using those two solutions there, and then we pick a value in 3 places: below the lower limit, between the limits, and above the upper limit 4. Okay, and then from that we can derive which inequalities and which limits satisfy the inequality above. Okay.